Problem number 6, we're being asked to match the inequality notation with the interval notation. A number line picture might help with remembering how to do this. So take a look at this first example here. X is less than 4. If I drew that on a number line, here's 4. I'm not including 4 because there's no equals. It's only numbers that are less than 4. Well, for interval notation, all you do is you look at that picture, you start with the number farthest to the left that you shaded in, that would be negative infinity, followed by a comma, then the number farthest to the right that's shaded in, that would be 4. Now, infinity always gets a parentheses. The number gets a parentheses if the circle is not filled in, meaning it's not included. It'll get a bracket if the circle is filled in, if the number is included. Well, I don't have that circle filled in. 4 is not part of the answer, so here would be the correct interval notation. Negative infinity, comma 4, and only parentheses. Okay, second example. 1 less than x less than or equal to 4. The better way to read that one is all numbers between 1 and 4. Now notice the 1 does not have an equals with it, so I'm going to have an open circle there. The 4 does have an equals, meaning it's included as part of the solution, so I will have that shaded in. And we're talking about all numbers in between. Well, interval notation is just number to the left, 1, comma, number to the right, 4. The 1 will have a parentheses, the 4 will have a bracket because it's filled in, and so there's my answer right there. The third example, all numbers, that means the whole thing, everything. All the numbers on the line are shaded in. So my number farthest to the left is negative infinity, comma, to the right would be positive infinity. I don't have the bracket issue to worry about, and so there's the answer there. Obviously, we know how this last one works, but let's draw it out. X is bigger than or equal to 4. Here's 4. I have an equals, so I'll color this in, and I'm coloring everything bigger. Well, number to the left is 4, comma, number to the right would be infinity because it goes on forever that way. The 4 would have a bracket, and so here's the answer right here. That's inequality notation and interval notation. Problem number 7, I'm given a function, f of x equals x squared, or you could write that y equals x squared. Let's first plug in some x values and get some outputs. It's very easy. All you have to do is square each x. So negative 3 times negative 3 would be 9. Here I'm going to get 4, 1, 0, and then 1, 4, 9. Just multiplying each x value by itself. So 1 times 1, 2 times 2, etc. If I want to draw a graph by hand, I would just plot the points and connect the dots. Let's see, negative 3, 9 is a little bit too high for this grid. I think 9 would be about there, so somewhere up here. Negative 2, comma 4, negative 1, 1, 0, 0, 1, comma 1, 2, comma 4, and 3, 9, again, would be way up here somewhere. And I'll go ahead and connect the dots. And you've probably drawn this picture before. We call it a parabola. Part C says, considering this same function, f of x equals x squared, state the domain of the function. The domain just means a list of every possible x you could ever stick into it. Well, you can square any number. So the domain is just anything. It's all real numbers. Even look at the graph. You can tell that eventually x equals 4 will show up on the graph. I mean, it'll be way up there, but it'll be on there. X equals 5 will show up. X equals 6. They'll all be on there. So the domain is all real numbers. In interval notation, that's the one that we wrote negative infinity to positive infinity. Okay, is it the same thing with the range? The range is a list of all the y values, the f of x values, the output values, all the ones you could ever get. Is that also just all real numbers? Well, the range is often pretty easy to tell from the graph. Take a look at this graph. It is not all real numbers because there are several y's that are never on this graph. These y's are never there. In fact, there is no negative y value anywhere on this picture. The lowest y value that I see is down here at 0. Now after that, every single y value above it would certainly happen. And that arrow means it's going to go on forever. So y equals 1 is on there, y equals 4 is on there, y equals 9 we had, and it's just going to keep going up from there. So the range would be all numbers 0 and up. Well, in interval notation, you would start with a 0, comma, infinity, meaning it goes on forever. Infinity always gets a parentheses. I am including the 0. 0 is itself the lowest y value, so I have a bracket there. All numbers from 0 to infinity, including 0. And then letter E reminds us about even functions and odd functions. An even function is symmetrical across the y-axis, meaning if you folded your paper right along the y-axis, the graph would land on itself. An odd function is symmetrical across the origin. That means if you turn the picture upside down, if you rotate it around 180 degrees, the graph would land on itself. Well, I hope it's pretty obvious to you in this case that this is an even function. That y-axis functions essentially as a mirror. If you folded the red part of the picture across the y-axis, it would land right on that blue part of the picture. And so this function is even.